Hello, everybody. Welcome to this Codit Luxembourg webinar. Today's topic is on getting started with IoT. We will give you more insights in how IoT projects are set up, some use cases and customer stories. Now, today we have foreseen two hosts for you. There is Maxime Dehaut, who is the lead architect at Codit Luxembourg, and he will be joined by Ralph Hostad, the digital acceleration lead at Proximus Luxembourg. Now, with their experience and know-how, they are the best placed to cover today's fascinating topic. Now, should you have any questions during this webinar, please use the Q&A tool. Maxime and Ralph, they will take your questions at the end of this webinar. And with that, I'm leaving you in the good virtual hands of Maxime and Ralph.
Thank you, Francis, and welcome everybody. So this webinar is based on a couple of findings. One, most of the IoT initiatives never land in the production environment. And two, and there are still several organizations wondering if IoT fits them even after a POC. During this webinar, we'll also draw the current IoT landscape and what an IoT adoption means. Ralph and I will also describe the impact of the 5G on IoT. We'll then review what the IoT infrastructure looks like and explain how to address some typical challenges. And then last but not least, we thought it would be interesting to share with you some of our customer stories and how they fit with the various points we would have discussed before. So my first question, Ralph, is more about the sectors and which sector would benefit from IoT. My assumption is that there are sectors that are more sensitive to IoT than others. Is that a fair and correct assumption? Ralph?
Okay, yeah, now I'm being unmuted. Can you hear me now?
Yes. Sorry,
yeah, okay, sorry, yeah, my microphone was constantly muting myself. So yeah, getting to your question, I don't think it's a question of which for which sectors it's really relevant, because pretty much all sectors are impacted. It's kind of like asking, if you're a car manufacturer, would you consider putting electronics in there? So it's more on the question, where is the use case? Why would you consider it? What are you going to do with it?
But based on that, what would be the main motivations for an organization to either transition to IoT or to extend a potential current IoT infrastructure then?
Yeah, so it depends on the question, on the person you ask that question to. Of course, on the top level, it's always, and that's in a company's interest, about either saving money or generating money. The way I would usually structure it is there are internal use cases and external use cases. Internal use cases typically relate in some way of improving your processes, giving you more of an overview, giving you insights on what's happening. External use cases are more focusing on potentially extrapolating your product portfolio. So think about you think about preventive maintenance. Are you doing that for your own machines because that improves to some extent the production, or are you thinking about selling preventive maintenance on top of the products that you're delivering to your customers?
Okay, cool. And looking at the near future, which strategy or technology should we keep an eye on?
Okay, so overall, the strategy is, if you are somewhat related to something that could be connected to the internet, you should definitely think about, like, do I have to do that? Do I have to join the crowd? And that's more or less a question of, the Stone Age did not end because people were running out of stones. If you look at technologies, the question is partially derived from your internal strategy is build or buy is one thing, of course. On the technology side, there are a lot of things happening currently. So Gaia X, I assume, if that really takes off, will be a main driver because it basically solves one of the problems we see in IoT environments today, and that's connecting your own stuff to that of other parties. Yeah, well, since you asked me about it, well, I think we have a slide covering that later on. 5G will also play, to some extent, a viable role.
Okay, thank you. As I mentioned in the intro, Ralph, there are still today a decent percentage of IoT initiatives that don't reach a production environment. How do you explain that? Is that normal? Is that frequent?
I think we see that still quite often, and the reasons for that are manifold. If you ask for a slightly simplified answer, I'd say people don't get their flight level right. So either they aim too low or they aim too high, and then they're running out of fuel before they reach their flight level. It's kind of like, to give you an analogy on that one, so over in between Christmas and New Year, you decide, okay, I need to do sports. And then if you aim too low, you simply, without any plan for what you want to do in running, you buy a pair of sneakers, you're bound to fail. And if you decide, well, I want to run a marathon within 1 week, you're also bound to fail, because then you're aiming too high. So somewhere in between is the right thing. And of course, you need to have some goal in mind. So you need to know where you're going. So of course, aiming for running a marathon is okay, but then you should at least plan a little bit ahead. And by the way, also staying in the analogy, if you find out that running is simply not your thing, you should quit. So there is the saying of kill your darlings, and some people just don't stick to it, and then they start developing stuff, and it gets more and more and bigger, and then at a certain point in time, it's too big to fail, and then you simply can't explain somebody why they should not look at the 10 million you have already invested.
Okay, so going back to your analogy and your marathon, so I believe you have, I would say, milestones, and that we can see at the moment, but could you illustrate them with some kind of practical use case?
Well, yeah, we have things in here, but yeah, I was just saying, can you blend them in? So I think if you look at it, it's a process. So visibility, transparency, prediction. You can also reformulate that in other things where you say, okay, visibility first. I'll build a dashboard at all. So there is no AI involved, nothing. It just tells you what is currently going on in the devices. They're just delivering some data. You can already build some cool cases out of that one. So that would be one milestone. That's real-time operation control. Then the next thing is you start to collect historical data, and you build a hierarchical data model, which gives you a little bit more overview of the whole thing. And that's still, both things are a little bit hindsight. You look behind of what has happened in the past, and from there, then you really start to build looking forward. You do insights and you build foresights. So predictions is something that preventive maintenance, it says, oh yeah, well, we know from the past that if this machine is making these funny noises at that and that frequency, it's most likely to fail within the next 10 hours. We know that from the past, so you do some predictions. And then you take it a little bit higher and you start to do the smart maintenance. So instead of using the intervals, you use all that experience and say, hey, you know what, forget about maintenance every 10,000 hours. We just do it based on the status of the machine. And then, of course, you can also take it to services, which I think is a little bit of extra, because that basically means you suddenly turn this into a product. So this is actually the process we see over here is horizontal, whereas in reality, it should be vertical going up, because you're climbing up the value chain.
Okay, thank you. So as Francis mentioned earlier, you are the digital transformation lead for Proximus Luxembourg. So I believe that 5G keeps you busy at the moment, well, hopefully. What is the connection between 5G and IoT?
Okay, well, 5G is right now the big buzzwords, and there's a lot of interesting things in there. There's a lot of new things in there, and there's also a lot of nonsense in there. So, for example, if you hear somebody saying, the connected car or the autonomous car will be the killer case for 5G, I say, no, because I don't want my car to stop when it's running out of network coverage. So probably not really a good case. Thing is, when you look back, we have to learn from the past as well. When 3G came out, a lot of people said, well, what did I need 3G for? And then once 3G was there, actually things like YouTube and watching online videos and streaming and WhatsApp and everything came out. So the technology was there first, and then came the use cases. So now with 5G, we're seeing something similar. People try desperately to develop 5G use cases, and they're struggling with that, and then they try to stretch them. There are good use cases, but you should always ask yourself, if you think, do I need 5G? First question you should ask yourself, and that must be a definitive yes, is, do I need a wireless network? Because if you could basically say, well, I'm doing it for stationary machines that are powered by electricity. Well, if you can get electricity to a machine, you can also connect it to a 1 gig or 10 gig Ethernet connection. So then there are 4 more questions. One is, and they're all connected to the features of 5G. 5G basically gives us higher volume. We all know that. It gives us higher speed. You can connect many devices. It gives us an added layer of security and slicing. So if you need any of those, then, and that could be any of those 4, then you actually have something where you can say, yeah, maybe 5G is something I could take a look at. You know what? I mean, we could talk for 4 hours on 5G. Why don't we take a little bit look at the down the rabbit hole and check on what's going on in the IoT ecosystem? So, hands over to you.
Thank you. Yeah. So the IoT ecosystem must be seen as, let's say, a set of silos that you can see on the screen now. And obviously, I will start with the devices. So the devices are acting with in the physical world, and these devices essentially they collect and create data. Now, depending on the device capabilities, the protocol they're using, the underlying platform, etc., these devices can dialogue directly with your backend system, but sometimes they don't. And unfortunately, it's quite frequent that these devices don't have that capability, and I'm going to address that a little bit further, but it's still an issue today. So there is still a way to do this kind of to keep on this communication between the device and the backend system. That's usually done through gateway. Again, we're going to see that a little bit later. Now, when these messages or data land, they reach the what we call the IoT platform. And this is where the data will be collected, stored in the right place, and so on. Then we move to the IoT platform as such, and this is where the automation takes place. So this is where, for instance, you have your business rules which are executed to process the data. You have potentially some anomaly detection that could take place, or this is where your system will raise some alerts based on the data processed. All these events, but also derived data, populate your data lake or data warehouse. And it's based on these that you can elaborate analytics, machine learning models. You can also extract insight. And all these information are related to what's going on in the physical world, but also what could happen potentially in the physical world. That's what the insight part. And then the last step, of course, is the operation. So, but it's also called the feedback layer. So this is where through reports or actionable item, you will feed back either the management, the operation team, but also you could feed back the information and commands to the device, which again interface with the physical world. And that's in short or high level what an IoT ecosystem is.
Okay, so from an overview that already looks quite complex, looking at all the different things. However, can you illustrate a little bit more on the different components, what's sitting where, and how that interfaces with each other? And
yeah, Yeah, sure. So the trend today is to move as much as you can towards the cloud. I think that's fairly obvious and clear. But and of course the trend is applicable to IoT as well. Nevertheless, it doesn't work 100% for an IoT ecosystem. You still need to keep a little bit on the edge, so on premise, and that's what I'm going to try to illustrate here. So a distributed IoT solution is based on 4 nodes. So on one side, you have the smart device that are talking to edge gateway, who are talking to micro data center, and then ultimately they talk to a cloud data center. And these 4 nodes are spread across 3 layers that you can see here. So the cloud, the fog, and the edge. Now, the whole idea of an IoT ecosystem, and it's particularly applicable for what run on premise, is to extend the cloud paradigm. And that's crucial to understand and appreciate. Yeah, even if you process something on-prem, you are extending what's happening in the cloud. And again, we will illustrate that a little bit later. So if I start with the right-hand side, so what happened in the cloud, we have these global data center, and this is why you can run your global application. They allow deployment of multi-location updates. They also allow you to execute large-scale analytics, for instance. But today, the cloud provider invest a decent amount of money into their regional data center. And the idea is to bring customer solutions, so your IoT solutions, closer to your own premise. That's really the idea. Nevertheless, and despite these strategies, it's not enough. And that's why we come to the fog layer, where we have micro data centers. They are here stored in a network layer or on-prem. And the purpose of these is to address specific needs such as latency, data privacy, and so on. So, for instance, as a telco, Proximus Luxembourg is particularly involved in this through the rise of 5G connectivity that was discussed earlier. It brings also new opportunities to customers thanks to a faster broadband. There is a reduced latency, of course, and something that should be considered, particularly if you have a lot of devices, is that thanks to 5G, you can support and manage a higher density of device. Then if we move one step further, or one tier further, we reach the edge layer. So this one contains small devices which can execute some logic with a very limited amount of resources. And then lastly, what you have to appreciate is that the closer you are to your device, the more bandwidth you have, and with a low latency. And that allows you to react quickly on some insights. So that means that the processing could happen on the edge side rather than on the fog or cloud side. And I'm going to illustrate that in a minute.
Okay. Now, I'll leave the cloud part to one of the big clouds, and the management, well, we can take care of that in the fog part, but on, let's say, on the IoT devices and the assets, so everything which is closer to the edge, because that's apparently the part that I need to take care of if I'm getting involved in this. What are the key features?
Okay, so the very first one, of course, is the device lifecycle management. Yeah, that's crucial, and within that one, probably the key feature is the provisioning. So it's to make sure that your devices can register and authenticate themselves in a secured way. So it speeds up the provisioning or registering, but also registration, sorry, but also it guarantees that these devices are talking to your platform only and don't spread the data all over the world. Once the provisioning is performed, of course, the device will naturally start exchanging data with you. What you need to make sure is that you are able to, or the device is able to re-provision itself in case of a security breach, for instance, or another issue that could happen. So that means that they, and I quote, a little bit autonomous here. Now, what you have to realize is that there are IoT device or edge device, sorry, and you have IoT device. And the difference is that an IoT device sends telemetry data only, where an IoT edge device does the same, but on top of that, is able to execute some kind of logic. And because it's executing some kind of logic, you should be able to update and adjust the configuration of these devices. And of course, doing that remotely. And then lastly, and because we're running a lot of logic that I was talking about, monitoring is crucial. Yeah, this will help you to understand the health of the device, the health of the services it's providing. And when I say health of the device, it can be, okay, my device is up and running, but it could also be, okay, it's up and running and it's sending telemetry data on a regular basis, so there is no down in terms of usage or consumption or whatsoever. The next one is device and data protection, and this these devices must be secured by design, and that's crucial. Yeah, secured by design, and you need to make sure that the communication channel is protected, so the device can only dialogue with your own infrastructure. So I go back a little bit to what I was saying earlier. The idea, of course, here in this case is to prevent triggering restricted or forbidden action in the physical world. And that brings me to the next point, which is, of course, these devices or edge components should convey data, but they should also convey commands. So you should be able to manage remotely these devices by sending them messages or a command that will trigger, for instance, an update, a reset, a reboot, you name it. And then the last point is, and I think you would expect these devices to perform some tasks on the edge and not using cloud resources. And again, I'm going to be back to that in a second.
Okay, well, so far so good. And I'd say, you know, starting from greenfield, we could probably take this this list. But I mean, reality is, because we're talking to people and companies who have already devices out there, and these devices are not necessarily all speaking the same languages. Some may have a serial protocol, other don't have anything, but maybe just some analog voltage that they're spitting out. And so the reality is, most of the clients never have a greenfield or cannot afford a greenfield approach, and they cannot simply say, oh yeah, good to know all these things, and we will consider them for all the machines that we'll buy in the future. But you usually starting with a bunch of diverse engines and the full zoo. So how do you actually manage that one?
So this is where it becomes extremely interesting to consider a field gateway. And the field gateway, to be short, is, let's call it a device at the moment, but I will elaborate a little bit more in a second. So it's a device that is located close to your on-prem devices. So in other words, it's a device that you could deploy in your own infrastructure. And this device will take in charge a couple of things like communication translator. So it will handle the different protocols, for instance, and convert them into a protocol that the cloud can understand. So it's a kind of facilitator. It will also convey not only the data, but the command from and to the IoT platform. And it also has the capability to run some kind of logic on itself. So that's, in short, what a field gateway is.
Okay. Can you get a little bit more on the field gateway?
Sure. So just to be clear, on this slide, I have few figures that you will see. They are extracted from a study done by IDC on industrial automation. Now, from our experience, it's equally applicable to other industries. So 85% of devices are not internet ready. So that means that they do not understand modern communication protocols. They don't understand modern reliable encryption technologies and so on. So they're pretty much designed to provide a simple functionality and maybe implement some communication interfaces, but nothing you should really trust, because it's and I quote, fairly basic. So that's a concern, and that Ralph just discussed. Field gateway come with native functionalities that would require a huge amount of development effort if you had to implement them by yourself. So these two are essentially the biggest benefit that you would see from a management perspective with regards to the field gateway. It's also important for you to be in a position where you can perform edge processing. So what I mean by that is that the data will be processed on the field gateway, so more on the edge side, rather than on the cloud side. And if you do that, then it is estimated that you can achieve up to 60% reduction on your cloud cost. So this is crucial, right? Because we see many customers who are transmitting all the data coming from the device, and I mean all the data that the device can produce, which, as you can imagine, represent a big volume of data, considering that these devices quite often send a message every second or even every 100 milliseconds, for instance. So, and this is mainly due to the fact that these devices do not understand yet how to filter the data. So you need to have that field gateway, to filter that, to apply this filter. And if you do so, then you will realize that you can do a clear saving in terms of transmission cost, storage cost, and also processing cost. And then having the capability to pre-process on the edge, it will definitely have an impact on of course, on these costs, but also effectivity. And that brings me to the next point, which is the network optimization. So imagine that you have multiple devices in your physical location, which is definitely the case, right? I can't believe that anyone has only one device lost somewhere. So what you could do is you could use what we call the message batching or message compression, which is a feature that it brings a real advantage to your IoT landscape. The message composition is another interesting feature. Basically, what it is that you can collect messages from different devices, you merge into one message, and then this message is conveyed to the platform. We can also do things like message queuing. So this is typically to address a potential issue with your network connection, like an interruption, for instance, but you still want to receive these messages on the field gateway. So at least they can be processed pretty much immediately. And what the gateway will do, well, it's typically queuing, right? So we'll queue this message, persist them into memory or potentially disk. And when the network connection is back, then all the message who are waiting in the queue will be transmitted. So at least you don't lose them. They've been processed, and on top of that, they are not lost. And then the last one, and I'm going to be fairly quick on this, is the fluttering capabilities. So this is a functionality or a feature that help you to deal with a limited bandwidth, and then you can prioritize. I'm going to spend too much time on this because it's quite detailed. And then the last one is it's crucial that the gateway gives you a consistent implementation of your infrastructure. Yeah, what you want is to make sure that if you have hundreds of devices, they have been treated equally, and particularly in terms of security, credential management, and so on.
Okay.
So
if you would want to build a full-fledged overview of everything that you can throw in there like a script. I know that's I know the next slide already, so I know that you have it, but it's my favorite one as I'm an engineer as well. That's what would be the idealish architecture look like?
Okay, well, there we go. You asked for it.
I knew it coming.
Okay, so if I make it really short, it's actually, and I know you're going to laugh at this, but it's a quite interesting summary, and I quote, of what we've been discussing so far. And I'll go through that very quickly. So on the left-hand side, you have the things, so the device, but you also have to consider that anything that produces data that can be ingested should be considered as a thing. Yeah, so as a device, and that's why you have all these things there. Then you have the gateway, and as we discussed, the gateway brings you real benefit in processing on the edge all these data, and they also facilitate the communication from your device to your IoT platform. But they can also storage. I mean, the good example I believe was the queue that I was mentioning earlier. But you don't necessarily have to use a queue. You can use other techniques that are on the screen. I'm not going to comment on that. Let's forget about the protocol. Yeah, protocol at this stage is detailed. Then on the IoT platform, again, you need, if you remember what I was mentioning about provisioning, you need a device management, and you also need an ingestion layer, which will receive these data, telemetry data, the command, etc., etc. And then you have the, well, you have the choice, yes and no. You need to have both paths, so the hot path and the cold path. So you need to have the streaming path, which is the hot path, and this is where you process the data in near real time. Yeah, the real time being on the gateway, the near real time being on the IoT platform. So this is typically where you will execute your machine learning model. You will decide which action, if there is any, should be triggered and sent back to the device, for instance, or maybe you would like to interact with an external system. So all of this should be done in streaming. Now, we're talking about these models, analytics models. They have to come from somewhere, and typically they come from the cold path environment, I would say. So this one is a bit slightly different. So it usually comes through ETL or batch processing. So you collect historical data, you store them, of course, and on top of that storage, then you create your analytical model. And just to be clear, these analytical model that includes rule-based, machine learning-based, but they can also include optimization-based, right? Now that you have all these data and paths, that means that you can plug your existing applications, whether it's reporting, BI solutions, but also it could be a logistic application, whatever, they can be connected to that platform. And then last but not least, it's crucial to have some kind of procedures and practices with regards to infrastructure, security, monitoring, and DevOps. And that's why I have called it the ideal-ish architecture.
Okay, now having seen the engineer's dream, we know what keeps you awake at night. I think maybe we want to go to some of the examples. So since I'm from the Proxima side, this is something new for me as well. So would be great if you can share some of the things on the things that have been actually implemented on behalf of Codit.
Sure. Yeah. Okay. So let's go through the first one. Of course, there is always one. So this company is in the food processing industry. And they were looking at, and I believe it's fairly similar to any industry, whether it's manufacturing or even logistics and things like this. So they always want to minimize waste, improve the quality, reduce the downtime, of course, have a better management of the energy used by the different machines, etc., etc. And the underlying objective is to have a better control on the cost, but of course, if you have better control on the cost, logically you should also have decent cost savings. Now, if I go a little bit further in the details, so these guys were gathering the data from the machine and generate insight through the platform. Now, the first need here was to elaborate a scalable architecture, considering that they had thousands of machines worldwide. And besides, some machines had no digitalization capabilities. So a little bit like what I was saying earlier. But they had the customer was determined to integrate these machines into the IoT platform. So what was recommended by us was a combination of Microsoft Azure and IoT technologies. The older equipment were retrofitted with, thanks to a gateway that Codit has built, which is a tool called Nebulous. And that helped to streamline and speed up also the delivery time in terms of the IoT project, of course. In terms of result, so the pilot has been a complete success and has opened door for our other projects. So the customer estimated that they could save up to 15% of the food waste. the labor cost was dramatically reduced, and the energy cost was also reduced by roughly 5%, which is, I believe, quite decent. If I move to another use case, and it's probably is the hub one. So just to be clear, this is a big customer actually, because this customer is based in CDG, Charles de Gaulle, which is one of the biggest airports in Europe. And they were looking for a solution to keep real-time track of passenger luggage. And with that information, the idea was to provide a kind of a service or an entry point for the airlines, so the airlines could have access to that data. So that's quite interesting, because here again we have this connection between the platform itself, the IoT platform, and an external system. So the biggest challenge was a drastic shift from an old and legacy system to a solution that combines IoT, cloud, and on-premise systems. So that's quite tricky. And considering the size of the project, the customer asked Microsoft to provide some recommendation in terms of partners, and that's where we enter the arena. So what we did first was to go through a kind of feasibility study that was compared with what Hub One has conceptualized, and we also assessed the value generation for the platform. What we did is let's be short, but we put in place an integration platform based on Azure, and the idea was that all the data would be processed on that platform and then sent from that platform to the different airline data center. And in terms of results, so as I said, today, and thanks to that hybrid approach, the airlines at Paris-Charles de Gaulle Airport receive real-time information about the passenger luggage. Besides, and that was the very interesting thing, is besides, Hub One has been able to reduce the operational cost as well. And that is it for the use case.
Okay. So maybe you want to start off with the takeaways, because I mean I got some things from the business side, but I'm sure there are a lot of from the technical side as well.
Yeah, so I won't be too long, but from a technical perspective, there are a couple of things to consider here. Yeah, so first of all, IoT is, you have to look at IoT from different angle, and that's probably why we're quite well positioned. When I say we, from a Codit perspective, is if you want to do IoT, of course you need devices, that's for sure, but you need an IoT platform, that's more than obvious. But the IoT platform implies also integration, which is something we've done for years. The IoT platform involves AI and machine learning, and for instance, we have expertise in Codit Luxembourg in terms of AI, machine learning, and optimization. And when you put all these components together, then it start make a lot of sense in terms of IoT. Now, and the last point I would like to make, and that's more again on the technical side, is today you cannot ignore what we've been discussing, i.e. the edge. If you ignore that, your IoT project will not be as successful as it could be.
Okay, yeah, and basically adding from the business side, I can only tick off all the 4 topics that you have on the list over here as well. So start at the core. So also take into consideration, what do you want to achieve? If you simply start off by saying, oh yeah, well, we need to build a data lake, you probably the chances that you will never get the money are quite high. Secondly, even if you get a little bit of money, you probably end up with a swamp because you have no clue what's on the inside. And even if you persuade your boss to sponsor the couple millions to build something huge, and then after 3 years, you have succeeded, and from an IT perspective, it's a big success. But then if you start asking yourself then, what are we going to do with this now that we have the data lake? Then it's probably, how did we say? Nice landing, wrong airport. So from that one, build on the foundations for AI, same thing. Don't start with a marathon. Start running, but with a goal that actually achievable and also meaningful to your business. And that's basically saying that pick your scenarios and set your targets right, so that you can always move a little bit forward and that you can extend it. That's from a business perspective the only way that you can get buy-in from the management, that you get some funding for future projects.